So you've done all the hard work. You containerized your application, you pushed it out to Google Kubernetes Engine, and hey, it's running. That is a huge win for sure. But, in that rush to get to production, there's one critical question that often gets pushed to the side.
And if we're being honest, for a lot of default deployments, the answer is probably not. I mean, getting an app up and running is one thing, but making sure it's actually defended against real-world threats, that's a whole different ballgame. So, let's get to work. We're going to take our application from a pretty vulnerable starting point and turn it into a hardened fortress.
Okay, so let's start with a scenario that I think is going to look really familiar to a lot of you. We've got a microservices app on GKE. It works, which is great, but it was probably built using some standard, off-the-shelf base images and then deployed with these wide-open, super permissive settings. This is our before picture. And yeah, it's a little scary.
This right here, this is our mission. It maps out the whole journey. We are moving from that vulnerable state you see on the left to the secure goal on the right. We're going to tackle each of these problems one by one, getting rid of those bloated, permissive images, finding all those hidden vulnerabilities, and most importantly, eliminating static keys and locking down the network. We're building a truly secure system.
First things first, security has to start at the absolute foundation, and for us, that's the container images themselves. Think about it. If the very building blocks of your application are insecure, then anything you build on top of them is just never going to be truly safe. So here's the deal. Using a generic base image like Ubuntu or Debian for your production app is a massive risk. These things are packed with tools your app doesn't need. A shell, package managers, all sorts of network utilities. Your app doesn't use them, but an attacker? They would love to find them. Our goal is to get to the right side of this slide, a tiny, stripped-down, production-focused image with the smallest possible attack surface.
So how do we actually get there? Well, it's a pretty straightforward three-step process. First, build your application on what's called a distroless base image. These images have literally nothing but your application and its direct dependencies. That's it. Second, you just flip a switch and enable vulnerability scanning in Google's artifact registry. It will automatically check your images for known security issues. And third, you sign your images. This gives you a guarantee they haven't been tampered with. This little pipeline right here is your assembly line for secure containers.
Okay, so our images are secure. Awesome. Now let's move up a layer to the environment, where they actually run. You see, a default GKE cluster, it's kind of like a town with no fences. Everybody can go everywhere, talk to everyone. It's time we build some walls.
And the main tool we're going to use to build those walls is the network policy. I love the analogy on this slide. It's perfect. It's a firewall, but for your individual pods. See, by default, there are no internal firewalls. Any pod can chat with any other pod. Network policies let us flip that default from allow everything to deny everything. Then we can poke very specific, tiny holes for only the traffic we actually need. And this shows you the impact just perfectly. Before, in that default open state, a compromised logging pod could maybe try to attack your database pod. But after we implement a least privilege policy, we explicitly say only the front end is allowed to talk to the back end. All other traffic? Blocked, by default. This one simple change makes it so much harder for an attacker to move around inside your cluster if they do get in.
Of course, network policies aren't our only tool. We also have to lock down who can do what inside the cluster. That's where role-based access control, or RBAC, comes in. And we should also use pod security standards to stop dangerous things from happening in the first place, like preventing pods from running as root. Think of these as the essential guardrails that keep our whole cluster safe.
We've secured our images, we've secured our cluster network. Now we get to what is, you could argue, the single most important security challenge in the cloud, how your application gets permission to talk to other services, like a database or a pub subtopic.
And I am not exaggerating here. Year after year, the #1 cause of major cloud security breaches is exposed credentials. It happens all the time. A developer accidentally commits a key file to a public GitHub repo, and literally within minutes, automated bots find it and start spinning up crypto miners, or worse, they start stealing your data.
This is what we're talking about. This JSON key file is a static, long-lived password to your cloud account. If this thing leaks, it's pretty much game over. The old way of doing things involved downloading this file and sticking it inside your pod, a process that is just filled with risk.
We have to get rid of the method on the left. We just have to. Static, long-lived key files need to be a thing of the past. The modern, secure way, it involves no files to manage at all, and instead uses credentials that are temporary and automatically rotated for you.
The solution on GKE for this is called workload identity, and it is a brilliant piece of engineering. It essentially links your Kubernetes service account to a Google Cloud Service account. This lets your pod get temporary, auto-rotating credentials for GCP APIs without ever seeing a JSON key file. There is simply no key to leak. This is the way.
All right. We've covered a ton of ground, right? We've transformed our application security posture layer by layer. So let's boil all of this down into a final, actionable checklist you can take right back to your team.
Here it is. If you are running anything on GKE today, this is your to-do list. Start with your images, lock them down with Destrolus, and get that scanning turned on. Then, implement network policies to build a zero-trust network. Tighten up your RBAC rules. And look, most importantly, if you do nothing else from this list, make it your mission to get rid of every single static service account key and move to workload identity.
And that pretty much brings us to the end. Just remember, perfect security isn't some destination you arrive at one day. It's a continuous process. It's about always improving, always raising the bar for attackers, and making small, smart, incremental changes just like the ones we talked about. So the real question is, which one of these is going to be your next step?